Hi, my name is Nick Matthes. I'm an instructor with Green Solutions International and owner and CEO of Illumination Solar Training Systems. I want to give you a walkthrough of our mobile solar training lab that I've developed at Illumination Solar Training Systems and is an integral part of the hands-on training we do at Green Solutions International. So our mobile solar training lab is developed to bring hands-on experiential training to any classroom setting, whether we are in a classroom that has a nice yard for us, whether we are on the road in remote locations, or like here, if we are setting up outside, wheeling this to a covered area where we can work on while we're getting a little bit of sprinkles of rain throughout the day, and then wheel it right into the classroom so that this hands-on aid becomes part of the classwork what the students get to experience from day one. So a few features of the mobile solar training lab is a full-size 6 solar module solar PV array. So this can work with a wide variety of full-size solar panels, solar modules, and it does not work on the small little briefcase style solar modules. So here the students are getting real-life experience handling full-size solar panels that they would use when they are working in the industry. And so it's an important part of our hands-on training that students get this experience and understand how to work with these sometimes clumsy, potentially hazardous solar arrays and get that experience in a controlled classroom setting. So now when students get to work out in the industry, they're familiar with the solar panels. They know how to handle them safely. They know the appropriate levels of personal protective equipment to just help reduce one of those barriers to entry for the students getting into the solar industry. You'll see our solar array comes with 6 solar modules and a ballasted racking system. So this allows us to set up the solar array right on any ground surface. We could set it up in this unused area. We could set it up in parking lots. We can put it on a flat roof, and we can even put it on the side of a hill. We can just make this work just about anywhere where we have enough footprint to build the solar array. And so another important part about using a real full-size solar modules and the array that the students will use when they get a job in the industry is that it allows students to understand the different wiring methods that are integral to that. So here we can see we're using full-size photovoltaic wires, and we are able to wire this in a couple different configurations to give students training on series and parallel electrical connections. So we've got this solar array set up here. We're still working on it during class. We got a little bit more to do with our wire management. But what we've had the students do is wire 3 series strings of 2 solar modules. So we've broken this array up into 3 separate circuits, and we've run each of those individually back through this wire tray that's typical of what you might use in the industry. It helps protect the wires and keep everything routed, and brings it back to here where we make our connection to our combiner box. And here's a very important electrical piece of equipment, our combiner box, where we're going to make parallel connections, but it's also a very important piece of equipment theoretically. As students learn the electrical theory and series and parallel connections and volts, amps, and watts, this brings those concepts to life. So not only have we done the math on the whiteboard, but we've also been able to build it, experience it, and then test it with a voltmeter so we can see in real life what happens when we're building series and parallel circuits, thus forth bringing Ohm's law to life. And then from the combiner box, we come into our DC disconnect box, or our DC circuit breaker panel, and this is kind of the hub where we feed multiple different pieces of equipment. We have our charge controller, which is going to be controlling the amount of charge that we give to the batteries. We've got our battery shunt, which is measuring the energy and the power in and out of the battery. And then we also have our surge protection. We have our grounding electrode conductor. And all of this ties back into our panel board. And then from that, we come to our sine wave inverter. And so this is our off-grid inverter that's going to take this 24 volts from our battery bank and turn it into usable alternating current. And then inside here, we also have our battery bank where we have 2 batteries. And so we're able to take students through each part of the system, through each component, and teach them how voltage and current are going to interact with each other as we build these series and parallel connections. And then once we start drawing energy outside of the inverter, we're able to analyze each individual section of this wiring system to understand how those values are changing. And so that was a very intentional design aspect to leave these wires exterior so that students are able to clamp on with an ammeter and read what amps are traveling through what wires. For our mobile solar training lab, we opted to go with the best quality equipment that's out there. And with this, we went with Victron Energy for our charge controller, shunt, batteries, and inverter. And so this gives students training on very robust equipment that's strong and very efficient and good to program. But it also gives advanced capabilities like Bluetooth connectivity. So as we build this in class, students are able to dial in on their phone and see what's happening in the charge controller just from their phone. And we're able to see the flow of electrons, where the electricity is going in every direction. And then we also have touch screen displays, so we don't need to have a telephone, but it's just an extra added feature. So that's a good overview of the standalone or battery-based or off-grid side of the trainer. And now let's take a look over here at what we have on the other side of this same training platform, the utility interactive trainer. Okay, so on the other side of this A-frame cart, we have our utility interactive or straight up grid-tied trainer. And so we're able to utilize the same 6 solar modules that the students assembled, but now what we're going to do is rewire the solar array so that we have just one string coming back of 2 wires, and we're going to run that at a higher voltage. And that's going to operate our utility interactive inverter, which traditionally runs at a higher voltage than our battery-based equipment. So much like the other side here, we've got some of the typical equipment that a student would see when they get a job in the solar industry. So the wires are going to come back to our junction box or combiner box and transition to building wiring, where here it comes to our utility interactive inverter. And then from the inverter, it comes out to our safety disconnect switch. And then from the disconnect switch, it comes back to our breaker panel, where it back feeds on real life-size breakers, and then back feeds through the utility meter, which we're able to plug into the wall and get a utility signal from. So now we're actually able to plug this into the wall, plug this into a power source, and energize this whole system with 240 or 208 volts, and operate our breaker panel and get our utility interactive inverter operational. So and then again, we have our grounding electrode system that comes off of here, and then just a heavy duty cord that is plug connected to energize this whole training lab. And so by showing the students how a utility interactive system goes together and how a standalone off-grid system goes together, doing those side by side, the students are able to grasp the concepts, the similarities and the differences between each different installation. One of the foundational premises of this mobile solar training lab is to train students, give them the opportunity to be trained on equipment that's representative of what they're going to use when they get a job in the solar industry. So from the full-size solar array to the professional equipment that's contained on the grid-tied and the off-grid side of the mobile solar training lab, our intention is to give students the hands-on competencies so they can feel comfortable working with this equipment, and they're trained on how to safely work with this equipment so that they can feel empowered to go forth and get jobs in the solar industry for long, fulfilling solar careers.